Hello, Algebra 2. Our notes for today are titled 13.3 Exponential Decay Functions. Yesterday in our notes, we looked at exponential growth functions. And our notes today are going to be similar to this. But when we think about exponential growth, our general form is f of x equals b to the power of x, but b is now between 0 and 1. So that's where it's different from growth. The b value is between 0 and 1. Okay, so we're going to look at some common bases for exponential decay, just like we looked at common bases for exponential growth. For the first, we have f of x is equal to 1/2 to the power of x. We're also going to look at f of x is equal to 1/10 to the power of x, and f of x equals 1/e to the power of x. All right, and we don't have graphs for each of those, but you could make a sketch. So let's just fill out their tables. We know that for exponential functions, there's not just one parent function table, but instead our parent function table is going to depend on the base. So for the first one, 1/2 to the x power. If I plug in 0 for x, anything to the 0 power is 1. And if I plug in 1, 1/2 to the first power is 1/2. Right? But what if I wanted nice whole numbers? What about plugging in -1? If I plug in -1, 1/2 to the -1 power would be 2. And I now have nice whole numbers, which are useful when trying to transform. I'm also going to add to my table y equals 0. And I'm going to highlight these values that I liked. I liked 0, 1, and -1, 2. For 1/10 to the power of x, I still have the 0.01 because if I plug in 0 for x, I get 1. If I plug in 1 for x, I get 1/10 though. And that's a really hard value to transform. So what if I plug in -1? Well, 1/10 to the -1 power is equal to 10. So that makes a nice whole number. And then of course I have my horizontal asymptote y equals 0. So the values I would prefer to use would be with these nice whole numbers. And lastly, we can see a base of e. E is a value on your calculator. You can also in Desmos, if you use E, it will give you that approximation for it. If I plug in 0 for x, I get 1. If I plug in 1 for x, I get 1/e. So that's not a nice number. But if I plug in -1, 1/e to the -1 power is e. And of course, a horizontal asymptote at y equals 0. Okay. So in general, my transformation equation is just like yesterday's. G of x equals a times b, where b is not a transformation value, but the base, to the power of x minus h plus k. And if we were to come up with a general table, our general table would be 0, 1, and then we decided we liked the -1 value better. And the relationship between this y value and the base was that it was the reciprocal. So in general, it would be the point -1, 1 over b, the reciprocal of b. And then we'll include our horizontal asymptote at y equals 0. So these are our reference points that we'll use when we're dealing with a decay function. And what makes this decay is that the base, the b value, is between 0 and 1. All right, so let's go ahead and get started with our examples. So the first, if we want to kind of break up our notes, the first section of our notes will be graphing transformations. All right, example 1, I am asked to graph g of x is equal to 3 times 1/2 to the power of x minus 2 minus 2. So first step, let's identify the transformation values. I know this is decay because the base is between 0 and 1, it's 1/2. A would equal 3, H would equal 2, and K would equal -2. So I'm ready to go ahead and make my tables. I'm going to move this a little bit. So I'll start off with my parent function table. I know this is decay, and the base is 1/2, so my points are 0, 1, -1, 2, and then my horizontal asymptote at y equals 0. My transformation table would consist of the transformations of x and the transformations of y. And the only value that affects x is the h. So I have x plus 2, giving me x values of 2 and 1. And my y value transformations would be 3y minus 2. Give me values of 1, 4, and y equals -2. So this is what will be graphed. Highlight that. So I have a point at 2, 1, 1, 4, and then a horizontal asymptote at y equals -2. So to graph, I'll graph just like I did yesterday, where I approach the horizontal asymptote. But now you can see that our graph is leveling off to the right. That's what's making it decay. So you can see it starts up high and then it levels off. It's decaying. All right, so that's how we can graph. Another example. example 2, I have g of x equals negative parentheses 1 over 4 to the power of x plus 2 plus 8. So 1/4 wasn't a base value that we talked about, but it does make it easier for graphing because some of those larger bases, like 1/10, really smaller bases, then create these really big numbers that are harder to graph. And so we can apply what we know about those common bases to a base of 1/4. In this equation, I have an a value of -1, a b value equal to, oops, I'm an h value equal to -2, and a k value equal to 8. Make my parent function table. I know it's decay because my base is between 0 and 1, making my values 0, 1, -1, and then the reciprocal of b, so 4, y equals 0. My transformation table, I think of the transformations on x and y. H is what affects x, so I have x minus 2. A and k affect y, so I have -y plus 8. My new x values are -2, -3. My new y values are 7, 4, and y equals 8. So I'm ready to graph. I think I can I copy this one? There we go. Here we go. So I'll go ahead and graph points at -2, 7. Oops. -3, 4. And then a horizontal asymptote at y equals 8. So you can see this has been reflected because the points are below the horizontal asymptote. And connect my points and approach the asymptote. All right. So that is graphing the transformations. So now we're going to move on to the next type of problem we could see, which is writing equations. And we'll do 2 examples here as well. Writing equations. All right. Example 1, we are given, this would be example 3 on our notes, but we are given this graph. The one that looks like, we'll pick this one first. So go ahead and put that in your notes. Make a sketch. So I would pause this video because you do need to make a sketch of that graph in your notes. It has a horizontal asymptote at y equals 4, a point at -3, 1, and -4, -2. So for this problem, I need to tell you what your base is. We're going to let b equal 1/2, a base of 1/2. And I can see that because it levels off on the right, it is a decay. It's just been reflected. And we'll go about solving this just like we did the problems yesterday. So I know that my horizontal asymptote is at y equals 4. And that tells me my graph has been moved up 4. So that's the k value. K equals 4. And then I know that the point closest to my horizontal asymptote is the point 0, 1 transformed. And on this graph, that's the point -3, 1. So the point -3, 1 has gone through the transformations of x plus h and ay plus k. So we can set up equations for ourselves. If we know that x plus h must result in -3, well, the x value that I added h to was 0, so 0 plus h equals -3, and h equals -3. I can also set up the equation ay plus k, and I know that results in 1. The original y value that I did this transformation to was also 1. So a times 1 plus our k value, k is 4, equals 1. So what's interesting here is just because 1 resulted in 1 doesn't mean that there wasn't a transformation. When we solve, we get a equals -3. So now I have my a, h, and k. G of x is equal to -3 times my base of 1/2 to the power of x plus 3, x plus 3 because it was x minus -3. And then k was 4, so plus 4. And I've written the equation based on the graph, right? A way to check would be to then, you could also plug it into the equation you got into Desmos, make sure that it gives you the graphs that you started with. So definitely a good way to check. All right, example 4. You'll want to pause this video. And the only point we're given is the point closest to the horizontal asymptote, 1, -2. And we're told the horizontal asymptote is at -4, y equals -4. All right, for this one, we will let b equal 1/4. We know that our horizontal asymptote is at y equals -4, which means our function has moved down 4. That represents k. K equals -4. I also know that the point 0, 1 transformed is now the point closest to the horizontal asymptote, which is 1, -2. You will always be given that point, so don't think like, oh, I don't know if it's that point. For the purposes of this class, that's the point you'll be given. 0, 1 transformed. It was 1, -2. So the point 1, -2 went through the transformations of x plus h and ay plus k. So we can set up equations. X plus h resulted in 1. The original x value that was transformed was 0. So h equals 1. Ay plus k resulted in a value of -2. The value that was originally transformed was a value of 1. My k value was -4. So minus 4 equals negative 2. This results in A equals positive 2. All right, so I know A, H, and K. Write my equation. G of x equals 2 times 1/4 to the power of x minus 1 minus 4, my K value. All right, and I ended up with a positive A value, which makes sense because it's above my horizontal asymptote. I know just based on looking at the graph that this is decay because it levels off to the right. Okay, so that is the end of our notes for today. Make sure to let me know if you have any questions.